In this video, we're going to be talking about notation. And while these aren't the most complicated ideas in physics we're going to be discussing this semester, these are really foundational. And without a shared understanding of notation, you won't be able to actually communicate what your ideas are, and you won't necessarily be able to interpret what the book is presenting to you. So we're going to go through some basics of notation and then talk about some examples of good and bad notation and how much information can actually be communicated in it. So the first thing I want to talk about is just what the different variables can represent and how we actually indicate that in notation. Now, I've shown here on the slides what you might see either in a slide or in the textbook, but I also want to give you some examples of what this looks like in handwriting. So the first thing is just a scalar. Now, this is a fancy term that means something that is not a vector. It can have units, such as kilograms, meters, or seconds. It also might not have units. For instance, just the number 2 is a scalar, or pi. So that could be any sort of variable. I've used n here, but it could be a, or z, or a Greek letter. That doesn't matter. There's nothing special about a scalar in how that variable is written. Where we get into special notation is with vectors. Now, I've written 3 ways here that a vector might appear, either in slides or print material. And a common way of denoting a vector is actually showing it bold. In handwriting, it's really hard to actually denote a bold variable, and I encourage you to not even try. The best way to write this in handwriting is to use a small arrow over the variable. So when I write a variable that is a vector, I write kind of a half arrow like that. You could also use a full arrow if you wanted, but make sure that you're making something very explicit when it's a vector, and don't try to just write a little bit heavier to imply bold. That won't be clear. So vectors will be written with arrows when you're writing them by hand. Now, something related to vectors is the idea of a magnitude, which is the length of the vector, its size. Now, the magnitude itself is a scalar, so you can write it as a normal variable. So for instance, if your vector is a, writing it as a vector makes it very clear that that's what you have. And if you just wanted to talk about its magnitude, you could write just the scalar without the vector symbol, the little arrow above it. The downside of writing this is if I'm not convinced you know exactly what you're doing, I might think that you've made a mistake here and actually are meaning the vector but forgot to write the arrow. So one of the best things you can do for a magnitude is to be very explicit. Using the 2 vertical bars means the magnitude of a vector. So writing it this way, where again a could be bold in print, makes it very clear that you mean the magnitude. Now, one thing that's going to come up again and again in notation is if you make it very clear to me what you mean, I then will know exactly what you mean. So if you wrote that a without the vector symbol is equal to the magnitude of a when you're actually writing out a problem, I will know that you mean the scalar value to mean the magnitude and that it wasn't just a mistake. So feel free to write that and use that notation, but be as clear as possible to communicate what you mean. Now, the last thing here is actually something that only appears in chapter 3. So this is kind of looking forward a little bit to what we'll talk about in the second week, but this is the idea of a unit vector. This actually is a vector that only signifies direction, so it's a little bit special, and it actually has a different symbol above it. It's not a full arrow, but it's a little hat or a caret. So if I wanted to write this, and there are different unit vectors, you could use k as the example here, or I is another common one, and you just give it a little hat. Again, if you were to write k without that hat, it would not be a unit vector, and I wouldn't necessarily know what you were referring to. So it's fairly important that when you're trying to communicate a specific type of quantity, whether it's a vector, a scalar, or a magnitude or a unit vector, that you're consistently using this notation so it's clear to the person looking at your work what you intend to mean.